Alright, we have a question here which says 50 grams of ice at minus 20 degrees Celsius is supplied thermal energy and gets converted to water with temperature 20 degrees Celsius. The question is to calculate the total energy required by the ice for this. For the 50 gram of ice to become water at 20 degrees Celsius, what is the total energy required? Now, let's look at the stages that happen here. Initially, we have ice, 50 gram of ice at minus 20 degrees Celsius. Finally, it becomes water at plus 20 degrees Celsius. But we also know that in between there's a stage where ice becomes water, the ice cube becomes water, and then it takes the properties of water from there on. This happens at 0 degrees Celsius, and this utilizes something called latent heat of fusion of ice. Ice becomes water. The temperature remains at that point at 0 degrees Celsius. At melting, there is no change in temperature, but there is an energy in the form of latent heat of fusion times mass. The mass of ice times the latent heat of fusion of ice is going to be the energy at this stage. So first, let's look at the stage where it becomes minus 20 to 0 degrees Celsius. We know that the thermal energy for that is given by Q equals mass times specific heat capacity times change in temperature. So it's going to be 50 grams, which we convert to kilograms, times the specific heat capacity of ice initially is 2200 joules per kg per Kelvin. So 2200 times the change in temperature is minus 20 to 0. So change is 20. We can take this in Celsius, not in Kelvin, not necessarily in Kelvin, because the magnitudes of Celsius and Kelvin are same. But for certain cases, mind you, we need to take the temperature in Kelvin. Otherwise, it may not work. But here, Celsius is okay. So this is for the step 1, minus 20 to 0. This is the energy required. Plus, at 0 degrees Celsius, latent heat of fusion of ice times the mass of ice. So that's going to be 50 times 10 power minus 3 times the latent heat of fusion of ice is 334 kilojoules. So it's going to be 334 times 10 power 3 joules. So this is going to be the energy, and still there the temperature is 0. Just ice becomes water, let's say, for some time, and this is the energy that's required for that, according to the formula latent heat of fusion times mass. Plus, from there on, 0 degrees Celsius, water becomes, it becomes 20 degrees Celsius water. So here it takes the specific heat capacities of water. So we again use this formula m times c times delta T. The mass is 50 times 10 power minus 3. And the specific heat capacity of water we need to take now, which is 4200 joules times the change in temperature. 0 to plus 20 is again 20 is the change. So this is the energy required there. So when ice changes from minus 20 to water of plus 20 degrees Celsius, this is the total energy that would be required. Let's simplify this. It becomes 50 times 10 power minus 3 is common. And here we have 44,000 plus 334,000 plus 84,000. When we add all of this and multiply by 50 times 10 power minus 3, we approximately get 23100 joules specifically, and we can say this is approximately 23 kilojoules. So this is the thermal energy required for this complete process.